Hey, what's up, guys? This is Chung here. Today we're going to talk about another LeetCode tree problem, which is 1123, lowest common ancestor of deepest leaves. Okay, let's take a look at this problem. So you're given a binary tree, and you need to find out the lowest common ancestor of its deepest leaves. Okay, so what does this mean? I'll draw a simple root here. So, for example, this one. So the deepest node of this one is like 2 and 3, right? So and then this one will be the the lowest common ancestor. So if we have a 4 and 5 here, right? So the lowest is it's comparing with the deepest, right? So in this case, the deepest is 2, right? That's the that's the level of the deepest nodes here, right? This node has 1, right? So it doesn't count. So we only care about the 2 here, right? So since that's the case, and then 2 will be the lowest common ancestor, right? Because 4 and 5 they have that's the only ancestor which have the which have both the left hand side to be the lowest leaves. Okay, and then I'm gonna draw another example to explain the lowest here. This is a little bit confusing. I believe that's why this problem gets like more downvotes than upvotes. So let's, for example, if there's a 6 here, right? So both 2 and 1, right? Both 2 and 1, they are they're both the valid candidates, right? So 2 is left and left and right. They are both have the deepest node, which is 4 and 5. And 1 also have like it's also valid, right? Because on the left side it can reach either 5 or 4 or 5. And on the right side, yeah, right. So on the right side, it can also reach 6 here. 6 is also one of the deepest leaves here. So in this case, the lowest means the the lowest level, which means 0 here, right? So this is a level 1, this is a level 2. So since 0 is small is lowest than 1, which means smaller, has a smaller level than 1, then the 1 will be the result in this case, not 2, but 1. Okay. Okay, so keep that in mind, right? So with that in mind, so how can we solve this problem, right? So with this kind of like tree problems, it's very common to think of a recursion way of traversing the node, right? Traversing the tree, right? Okay, so since in this case, let's say, so what can make a node be a candidate, right? First, right? So we can see the left sub, the left and the right, right? So we can see here, so the left deepest level and the right deepest level has to be the same, right? If there's no 6 here, so the right side the level will be 1 and the left side will be 2, right? So first, left and right has to be the same. And what? And we also need like a deepest level because we're looking for the deepest nodes, right? So the deepest node means like we'll be needing like to maintain a global variable to keep maintaining the deepest level I mean this tree have, right? And then we check if the left and right are the same. The left deepest level can reach is the same as the right side, and then if they are also equal to the deepest level itself, right? Why? Because let's say for example if there's no 6 here, right? If just 3 here, there's no left and right, but left and right they're both the same because there's this 0 here, so the level will be 1 here, right? But the deepest level is 2. 1 is not the same as the deepest level, so this one is not a candidate. Okay. Okay, so let's start coding here. So first we're gonna have like helper function here, right? So the helper function, what it does get the deepest. deepest level, right? Basically, this node can reach, right? And on the outside, we're gonna like we discussed, we're gonna maintain like a deepest level, right? Deepest level equals to 0, and then answer equals to none, and we're gonna call it get deepest level. And then we're gonna call this one got roots and 0, right? And then in the end we just return the answer, right? So keep in mind, so we need to traverse from uh from bottom up, right? That's how we can keep getting that can make sure we'll be getting the lowest common ancestor in the end, right? We cannot do a top down. So for bottom up, then we have to do a a pre-order traverse, right? So with pre-order traverse, we'll reach all the way to the, sorry, not the pre-order, uh the post-order traverse. So which means we'll reach the left, right, and then in the end, we traverse the root node in the end. So we do this. If not, every time when we reach a new level, we'll update this level, right, with the current one, right? Then if not, no, right, we do a sanity check here. If it's not, we just return the level here, right? And then the left level, right? Basically, that's the left deepest level it can reach, right? We'll get that first. Deepest level node dot left, right? So, and since we're maintaining we keep tracking of the deepest level, we're gonna also passing this level and plus one to the next level, right? So that's how we keep track of the deepest level. Same thing for the left side, right? Right. Right. So that's how we do the post order traverse, because we're gonna reach all the way to the left, right? And then all the way to the right. So in that case, we can make sure before we processing anything, we already have the deepest level, right? We go left to the end, and we go to the right to the end, right? So we already traverse to the leftmost node and the rightmost node. Then we know basically we already traversed the left side and the right side. Then we know we have already seen the deepest level, right? So then we can just start processing the current node here, right? If left level equals to right level and equals to what? Equals to the deepest level, right? Then we just set this one to the current node, basically. Yeah, here. Since we're doing the using a global, we're updating a global variable, we have to mark them non-local here, right? So, and then here it's return remember this method is get the deepest level of the current node, right? So what's the deepest level of the current node? It's the which one is a bigger, which one is the bigger one from left and right, right? So we simply do a left node level and right level here, right? Yeah, I think that should do it. Cool. Yeah. So yeah, basically that's it for this problem. So pretty straightforward. We just first we traverse to the left and then to the right, right? Basically we traverse all the trees first to get the to get the deepest level here. And then once we have that, we will like we'll keep we'll compare the left deepest level and the right deepest level. If they are the same as the current deepest level, and then we'll assume this is like a valid result, and we keep going from bottom up, and then in the end we'll have the lowest result, right? Cool guys, I think yeah, thank you so much for watching the video. Yeah, uh, until next time, yeah, I'll be seeing you guys soon. Thank you. Bye bye.